Hello everyone, welcome to the last summer class. This is July 24th. This is the 10 a.m. class. This is what we started with today, so go ahead and copy this down. If you were not here, I talked with each parent briefly about what each student should be going into next year. According to what they've done on those homework pages, those were actually the pre-test for Saxon. Some of the students, I might have told you a number, but if you know that your student didn't actually do the papers by themselves, that might be a little bit off, okay? All right, so we're gonna take a look at these. So all of you should be able to do this, so go ahead and push pause and try it and then come back and check, okay? All right, the one thing we looked at, and I think it can really help, is when you're adding or subtracting, what we were looking at here is a pizza. Okay? In this pizza, you have a half. In this one, you have one slice out of 5. Now, are these the same size slices? If you had a pizza that was like this and you got one slice, or you had a pizza like this and had one slice, which person would you rather be? Okay, obviously these slices are not equal. Whenever you add or subtract, your denominator, your slices of pizza, must be the same, okay? There are 2 slices here, there are 5 slices here. Even though it's out of the same pizza, you can't put these together. Okay, so whenever you're working with something like this, you have to get these into common denominators. The way we do that, okay, is, can you take this and glue your pieces back together? No, you can't. So this can't be glued back together. So we're gonna have to see if this one can get to this number, okay? So we're gonna count by 2s. So 2, 4, 6, 8, 10. Well, it never reached the 5. So that means we're going to have to look at the 5 and count by 5s. Okay? Instantly, we have a number that they both agree on. Okay? So our common denominator is going to be that 10. And we're going to still add. Now, 2 times what gave us 10? Well, that was 1, 2, 3, 4, 5. We did 2 times 5. Okay, whatever you do to the bottom, you're going to do to the top. So we're going to multiply this by 5, and our new fraction is 5/10. Okay, the next one, all we had to multiply by was 2. Okay, so again, whatever you do to the bottom, you have to do to the top, and that gives us 2. So we now have the same amount of pizza slices, okay, which is very important, and we can go ahead and put those together. So in one pizza, we have 10 slices, and we have 5 of those we're going to put together. In this pizza, we have 10 slices, and we have 2 of those. So 5 plus 2 gives us 7. So we have 7/10 of a pizza available, okay? The main thing is whenever you add or subtract, they must have common denominators, or they must have the same amount of slices in the pizza, okay? If you look at the next one, you can see, again, they are not the same amount of slices, okay? This has 6 slices in this pizza. This has 12 slices, okay? You can't glue your 12 pieces back together. You just can't do it. So 12 is the smallest number it could be, but let's see if it works. So we're going to count by 6, and we can see the next number is 12, okay? Those 2 agree. That is our new common denominator. Okay, so we have 12 and 12. We are not changing that second number at all, so I'm just going to bring that 5 down. All right. Now, we counted by 6s 2 times to get the 12. whatever you do to the bottom, to the denominator, you're going to have to do to the top. So we're also going to multiply this one by 2, which gives us 10. Now, we have the same amount of pizza slices. We have 12 slices of pizza, okay? You started with a pizza that has 10 slices. Somebody already got rid of 2 of them. And then you ate 5 slices. How much is left? Okay, you have 5 slices out of the original pie that had 12 pieces. Okay? Key thing. When you're adding or subtracting, you must have a common denominator, okay? You can't compare pizzas that have 2 different amounts of slices, okay? This slice is not anything like that slice, okay? You can't compare these. You must make them have common denominators, okay? Now, we've done some work with mixed numbers, but I was finding it was a little bit foggy with some, so let's try this one again. This we're going to be adding. We can see the denominators are not alike, but we have a problem. We have mixed numbers right now. So the first thing we're going to do is, in this one, we can actually just work with the fractions, or you can create mixed numbers for both, improper fractions with both of these, okay? But what we're going to do is there's 1 whole pizza that's been used, and there's 2 whole pizzas here, okay? That gives you a total of 3 whole pizzas already. Okay. Okay, so we have 3 whole pizzas, and we're just going to look at the 3/8 and the 1/3. Okay, so we have 3/8 plus 1/3. Okay, these, do they have the same amount of pizza slices? No, they do not. Their denominators do not match, and we have to make them match before we can add them together, okay? So we're gonna count by, we can't put the 8 back together, so let's start with our smaller number. We're gonna count by 3. So it's 3, 6, 9, 12, 15, oh goodness, 18. Let's try over here. We're not matching anything yet. 16, 24, still not matching, so let's keep going down here. This is 3, 4, 5, 6, 7, and there's 8. Okay, and you can see they finally match up. And sometimes that's what happens. It goes a long time. So our common denominator is going to be 24. And we're still adding these. Okay, so now we have the same amount of pizza slices. But now we have to figure out how many slices we have, what our numerator is. Okay, this we were counting by 8. We had 1, 2, 3. So we multiplied 8 times 3. Okay. Whatever you do to the bottom, you're going to have to do to the top. So 3 times 3 gave us our 9. Okay. The next one, this was counting by 3s, 1, 2, 3, 4, 5, 6, 7, 8. We did 3 times 8. Okay, whatever we do to the bottom, we're going to do to the top. So that's 1 times 8, which is just 8. Now we have common denominators. We've adjusted the numerators, so now we can go ahead and add. So 9 plus 8 is 17 over 24. Okay, now we want to look at that for a minute. Okay, whenever we're dealing with fractions, we do want to check and see, can we simplify this? Now I know 17 is a prime number. 1 times 17 are the only factors. That means there is nothing that's going to agree between these numbers. So this is in simplest form. So don't forget though to put it back up here with the 3 pizzas you already have. So our final answer is 3 and 17/24. Okay. All right, so whenever you're adding or subtracting, you need to pay attention to your denominator. And I know you've all had that, but you need to make sure that you get comfortable with that fact. but does that hold when you multiply or divide? Okay, and you should know that, but we'll take a look. So let's take 1 1/2 times 2 4/15. Okay, so again, you should be able to do this. Go ahead and push pause and try it yourself, and then come on back and check. All right, so the first thing we need to do is we need to take care of the mixed number. Unlike the addition, you actually have to turn this back into an improper fraction. Okay, remember the algebra teacher likes the improper fraction, and if we had improper fractions, we could do this right away. But if you're in middle school, they like mixed numbers, so we have to take it back to the improper fraction. What you do is you take your whole number times the denominator, so this is that, okay, plus whatever was in your numerator. Okay, your denominator is going to remain the same. Okay. 1 times 2 is 2, 2 plus 1 is 3, so you have a numerator of 3 and a denominator of 2. Times, okay, you take your whole number, which is the 2, times your denominator, which is the 15, plus the numerator, which is 4. You still have a denominator of 15. Okay. So 2 times 15 is 30. 30 plus 4 is 34 over 15. And we're going to be multiplying those. Now, you might go ahead and multiply those right away, but these numbers are getting bigger. I would suggest that you look to see if we could divide anything out, okay? So what does that mean? Well, 3 is a prime number, right? 2 is a prime number. There's no other way to change them around. The only other factor they have is 1. It's not going to really help. But I know that 15 is really 3 times 5. Do you see how I have a 3 in the numerator and a denominator? That's like saying I have 3 divided by 3. Well, I know 3 divided by 3 is 1. So I also know that 3 divided by 3 is 1. Okay. Now, I also know that this is an even number, okay, because it ends in a 2, 4, 6, 8, 0. So I know 2 is going to go in here, okay? I know that it will be 2 times, well, 2 goes into 3 one time, 1 left over, so I have 14 now. 2 goes into 14 17 times, okay? Again, I know 2 divided by 2 is 1. I have just made my problem so much easier. This is just 1. And over here, all I'm left with is 17 and a 5. Okay? If you are in algebra, we leave it as this, an improper fraction. But we've talked about the fact that middle school teachers are not going to want that. Okay, so now we have to turn this back into a mixed number. So 5 goes into 17, how many times? What you're really thinking in your mind is, okay, 5 goes into 17, well that's 3 times, that's 15, leaving me with 2. That means 5 goes into 17 3 times, remainder of 2. Okay, and that is your new answer. Okay. Now, let's try another one. So whenever you multiply or divide, you need to take care of the mixed number, turn it back into an improper fraction before you can do anything else. All right, so let's take a look at this one. 25 divided by 3 3/4. Again, you should be able to do this, so you could push pause and go ahead and try it on your own and then come back and check it. Okay, if we were working this problem, the first thing we would see is this part here. We need to change that, okay? We need to turn it into an improper fraction. So to do that, we're going to take the whole number times the denominator plus the numerator, the leftover piece. And we're going to keep the denominator of 4. Okay? 3 times 4 is 12. 12 plus 3 is 15. So our new number is 15 fourths. So that means our problem is 25 divided by 15 fourths. Okay. The next thing you should do right away is we're going to put a 1 under that 25 just to make it a little bit easier. From there, we have 25 over 1, but we don't like to divide by a fraction. Instead, we are going to multiply by the reciprocal, that flip. So that's going to be 4 over 15. Now we're back over in one of these. Okay? Now, if I'm looking at this problem, if I just multiplied through, I'd have 100 over 15. But we don't want to do that because 15 and 100 could be reduced. I like to do it now before I get to those big numbers. I know that 25 is 5 times 5. Okay? I also know that 15 is 5 times 3. Okay? So what we're going to do is we're just going to cross those out. 5 divided by 5 is really just 1. They go away. All right? What you're left with then is 5 times 4, which is 20, and 1 times 3, which is 3. It's a lot easier if you'll take care of simplifying it before you do the problem. Now, again, algebra, you would leave it like this, the 20 over 3. Middle school, you're going to need a mixed number. So we're actually doing the reverse of this. So 20 divided by 3, okay? So 3 goes into 20 how many times? Well, I know 3 times 6 is 18. That leaves 2 left over, which would have been this number. So I have 2 left over out of the 3. Okay. So those are some problems we looked at today, or some similar problems we looked at today. All right, now we're going to shift gears a little bit, and we're going to start solving some equations. Today we did equations that involved some fractions and some decimals. So we're going to look at some more of those to continue to get some practice on those. Okay, let's look at this one. X minus, okay, so 0.58. Do you remember how we say that? Right, 58 hundredths equals 1 and 39 hundredths. Okay, so we want to be careful that we're pronouncing these the right way. Okay, so you should be able to do this. Go ahead and push pause and solve the equation. We're solving for x. Okay, so here we go. We want to solve for x. We want the 58 hundredths to cross the road, go to the other side. To do that, we are going to do the opposite. The opposite of minus 58 hundredths is plus 58 hundredths. So we're going to add that to both sides. Now be careful. When you're dealing with a decimal, line the decimals up. Okay, that's very important. Okay. When you do that, you have x equals, okay, you're going to start here. 9 plus 8 is 17, carry your 1. 3 plus 5 is 8, 8 plus 1 is 9. And then bring down the 1. So this answer is 1 and 97 hundredths. In this next one, right, we're again solving for the variable. The variable is n. So we need to take the 6 1/5 to the other side. It's going to cross the road. Okay, and Paul, I believe you said the crosswalk. It's got to cross over on the crosswalk. There's our crosswalk, so we're going to cross over. Okay? To do that, we're going to add the opposite. The opposite of a positive 6 1/5 is we're going to subtract the 6 1/5 from both sides. Those go away. We're left with n. Now we have to be careful here, okay? Think back to our pizza slices. Do we have a pizza with the same slices? Yes, we do. We have common denominators. We have 5 slices and 5 slices, so we're good to go. So 2 minus 1 is 1/5, and then 8 minus 6 is your 2. We have 2 and 1/5. Okay. So you can see, you can practice those elementary and middle school problems with your fractions, mixed numbers, and decimals, but we're still doing algebra. So you're kind of mixing both worlds and getting the best of both. We did talk about, parents, that if your child is in middle school, chances are they're not going to see any more graphing, they're not going to see any more solving equations, and you really don't want them to lose that. But these videos that we've been doing for the spring and the summer, they will remain up, they won't go away. You have your list. I will send you the summer list with all the links. Go and watch those here and there. Don't let your student forget these things and have to restart. Chances are it will come back to them when they get to algebra and pre-algebra, but just keep it in there if you have a chance. Okay, so the next thing we're going to look at is, let's see here, let's find one using some special properties. Here we go. Negative 8a plus 6 times the quantity, a plus 7, equals 1. Okay? We're going to take a look at this. So we're going to solve for a. But if you notice, we have 2 a's, okay? What else should you be noticing about this problem? Right? It has parentheses, so that could be PEMDAS, but this isn't like the problems we started with. So that means we're going to be using the distributive property. What that means is we are distributing that 6 to all the pieces inside, to the a and to the 7, right? Which will leave us with, there's our negative 8a, that hasn't changed, plus 6 times your a, okay, that's the first piece. Keep the sign, and now you're going to have 6 times the 7, still equal to 1. Okay? The next step we need to do is we need to just make it look cleaner because we can do something with these. 6 times a is really 6a. 6 times 7 is 42. Still equal to 1, and we still have a negative 8a over here. Okay, what's the next step? It still doesn't quite look like what we've been solving in our equations. Yes, you do want to combine like terms. So here you have negative 8a. You owe me 8, and then you get 6 for your allowance. What are you left with? Well, you're still in the hole. So you're still negative, but now you're 2a. Okay? Plus 42 equals 1. Okay? If you were unsure before, now you should be able to solve this, so push pause and go ahead and solve the problem. Okay, so we're solving for A. That means the 42 has to go to the other side. Those are the aunts and uncles, they need to go home. To do that, we're going to do the opposite. The opposite of a plus 42 is minus 42. Okay. We're left with negative 2a equals. You have $1, you buy something for $42. Well, you are very much in the hole, aren't you? You now have $41. Okay. We want to solve for A. That still remains the same. We want to get the 2 to the other side. But this time, don't forget, this is like the mom and dad. Okay, 2 times A. That is close. So what we have to do is we have to divide that apart. We have to break it apart. The opposite of 2 times A is to divide. So we're going to divide both sides by the negative 2. Okay, those 2's are going to cancel out, leaving you with A equals, again, the negative divided by negative, it's like a magnet, it becomes positive, 41 over 2. Okay, if you were in middle school, 41 divided by 2 is 20. And then you have 1 piece left over. Okay, so we've done quite a few of those over, let's see here, goodness, the whole time, spring and summer. So we've had 13 lessons if you've participated in both of those. So you've had 13 different weeks that we've worked on this concept. Okay, so you should be pretty good with that right now. All right, and then one last thing that we have worked on is graphing. Y equals 1/4 x plus 2. Okay. When you get to algebra, you'll be doing this by slope-intercept, and we've talked about that quite a few times. Slope-intercept is of the form y equals mx plus b. Okay? We can see that it's already solved for y, so we could go ahead and graph it right away. Okay, so I'm going to set up my graph. And you will be doing a table. We know y equals 1/4 x plus 2. Okay? What is the first point we always put on our graph? And that's when x equals 0. When x equals 0, that means we have 1/4 times 0, which is 0, and 0 plus 2 leaves us with 2. Okay? So your ordered pair is 0, 2. Which means we have 0 in the x direction, and we have 2 in the y direction. Notice, that's this number here. That is your y-intercept. Okay? And in this, it would be your b value. Okay? So if you're in algebra or pre-algebra, you want to be using that information, and if you're not yet, you will be, so there's your information. All right, pick some more X's. 2 points make a line. 3 points, we can check and make sure we did it correctly. So go pick some more X's and graph them, okay? And then come on back and check. All right, I'm going to be very careful when I pick my X's. 1/4 times my X. If I pick numbers that are multiples of 4, I'm going to make it a lot easier for myself. For instance, if I pick when X is 4, that says 1/4 times 4, okay? Remember, we could stick a 1 under there. Notice that cancels out to 1. And then I have 1 plus 2, which is 3. That's a lot easier than having a fraction answer. Okay, so if I had that one, I'd come over here and my X, 4 in the X direction, make sure you go in the positive X, and 3 in the Y direction gives me a point right about there. So if you're in pre-algebra or algebra, you might want to be doing this on graph paper or taking your notes and such in graph paper. Probably make it a little bit easier, but it's okay. Now, using the same idea, I'm going to try -4, because that means 1/4 times -4. Again, those are going to cancel out, right? Leaving me with -1 though. Be careful, this time it's -1. Plus 2. You owe me $1, you have $2, that leaves me with 1. My ordered pair would be -4, 1, X comma Y. So -4 owes on this side and 1, so it'd be right about there. Okay, 2 points make a line. I like to have 3 just to check, make sure I didn't make any errors. We're going to draw our line. It needs to have the arrows because it continues indefinitely. It's a line, so it doesn't stop. Okay? Now, we always read from left to right, so are we going uphill or are we going downhill? Okay, and when you look at that, we're going up the hill. So do you think that is positive or negative? Yep, it is positive. Okay. This is actually your slope. This information here is your M, which is your slope. And you can see that right here. It's whatever number's in front of the X. Okay? So thank you for joining me this summer and the fall or spring. And if you would like to take lessons with me in the fall, I need to know when you could actually do it. I am available every day except Friday. I don't want to do it on the weekends. It needs to be after, it'll be at 4 o'clock. There'll be 2 choices, and I can even have this one class with 2 different options going on. You can either take the class and it will not be for a grade. That means you are in charge of your tests, your quizzes, whatever you want to do to assess. The other choice is I would be in charge of everything. I will hand you a grade at the end. Either way, I can have the kids in the same class. It's not a big deal. It's just who's going to do the grading. If we do that, it'll be an hour class once a week. I will cover everything that you should cover that week. From there, I'll give homework assignments. It's up to you parents to get it done, to check it, so on and so forth. I'll probably do a video, just a short one to go over, maybe pick 1 or 2 problems through the week that I think they might be struggling with. And also in that, I thought once a month, my older 2, which have already completed all the Saxon and actually have credits in Algebra 2, college algebra and everything, they could also hold a study session once a month, bring in all those homework problems that you've not been able to get figured out yet, and they'll walk you through. Okay, so there's a couple different options there. I need to know when you would be available, or when you're not available, I should say. It would always be at 4 o'clock. and which option you would prefer, a graded option or just kind of telling you, teaching, okay? So I've enjoyed working with all of you, and good luck.